So we have the function f of t equals to cosine of a of t. So in order to find the Laplace transform of this given function, we are going to convert it to its equivalent Euler's form. So in its Euler form will be given by e raised to the power of I times at plus e raised to the power of negative I times at divided by 2. So that means finding the Laplace transform of cosine of at is equivalent to finding the Laplace transform of its Euler's form. So e raised to the power of I times at plus e raised to the power of negative I times at whole divided by 2. Now we can use the property of the linearity of Laplace transform. So that means we can take 1 over 2 as the common term. This will be multiplied to the Laplace transform of e raised to the power of iat plus the Laplace transform of e raised to the power of negative iat, which will be equals to half times, so the Laplace transform of e raised to the power of iat. So we can here use the Laplace transform of e raised to the power of at, which is simply 1 over s minus a. So that gives us 1 over s minus a. So a here is I times a plus 1 over s minus of negative ia. So let's combine the two terms. So we have 1 over 2 multiplied to 1 over s minus ia plus 1 over s plus I times a, which will be equals to half multiplied to s minus ia times s plus ia, and in the numerator we have s plus ia plus s minus I times a. So the ia and ia gets cancelled. We have half multiplied to 2s in the numerator divided by s minus ia times s plus ia. So it has the form s squared minus ia whole squared. So that will be equals to, so the 2 and 2 gets cancelled. So we have s divided by s squared minus I squared a squared. We know that I squared is negative 1. So that gives us s squared plus a squared, since I is equals to negative 1. So this is the Laplace transform of the cosine function cosine of a of t. So if we have a equals to 1, if a is equals to 1, so that means Laplace transform of simply the cosine function will be s divided by s squared plus 1.